Welcome to Algebra 2, Semester 2, Unit 11, Section 6.3. Okay, today we're going to be looking at performing operations and compositions of functions. Here's what we look at. With addition, what you've got is you're talking about functions when you have an equation like this, where we show the function h of x is the combination of f of x added with g of x. So what you really have to do is you have to look at what f of x is said to be. What equation is f of x equal to? Well, it's equal to 5x, so we write 5x in there. And now we look at what g of x is equal to. It's equal to x plus 2, so we just put plus x plus 2. So this is our f of x, and this is our g of x. Not that you need parentheses around them, it doesn't change values at all. We have 5x plus x would be 6x, and then we have a 2 there. So h of x, when we have combined those two functions, equals 6x plus 2. Now in subtraction, we do the same thing. We bring in our values, which is 5x, minus our g of x is x plus 2. You need to make sure and use parentheses on that one for sure, because you have to bring that negative throughout that second term. So you would have 5x minus x, which would be 4x, and then you have a negative times positive 2 is negative 2. So in this situation, the difference between function f of x and function g of x is h of x, and the difference is equal to 4x minus 2. Okay, the next one, f of x times g of x. So this time we have to take 5x for the f of x, and we set it right next to the parentheses with the x plus 2 for g of x. Now we would take and we would multiply. 5x times x would be 5x squared. 5x times 2 would be 10x. And that is what the product of f of x and g of x equals. And in this case, we've represented h of x as the product. Okay, in division, we do the same thing. We want f of x on the top in the numerator, so we write 5x up there. In the bottom, we want g of x, which is x plus 2. Now, a question for you. Why can't we reduce by factoring out or reducing the x's there? It would not be correct to do that, but I want to ask you, why can't we? If you say it's because this one is not being multiplied and it's being added instead, you are exactly correct. In order to reduce, you can only reduce factors, so they have to be multiplied. This x would have to be being multiplied by whatever it's next to. So that's why you can't reduce. So let's do a few more of these. In the next section, we have f of x equal to 4x to the 1/2, and g of x equal to negative 9x to the 1/2. Okay, so if we add them together, we have 4x to the 1/2 plus negative 9x to the 1/2. Well, we can factor out our x to the 1/2. We're going to multiply it by whatever else we have here. 4 plus a negative 9 would be negative 5. So there's our final answer, negative 5 times x to the 1/2. You can look at those as like terms as well. Okay, now we're subtracting these. F of x, 4x to the 1/2 minus negative 9x to the 1/2 Well, this time, we can see two negatives would make a positive, so we actually have 4x to the 1/2 plus 9x to the 1/2. We can factor out the like terms. X to the 1/2 comes down into our answer, and 4 plus 9 is 13. Okay. Next section. I'd like to do this one real quickly, do the multiplication. So we have f of x is represented by 6x. G of x is equal to x to the 3/4. This would be x to the 4/4 we'll write instead of just leaving it as a 1, because we know that we're going to add their exponents when we multiply. So this would be 6 times 1 is 6. X to the 4/4 plus 3/4 equals 6x to the 7/4. Okay. Let's do that division one while we're looking up there in that section. So we have f of x is our 6x right over here in your direction. So we put it up on top, 6x over x to the 3/4. Well, we know when we're dividing same base, we have to subtract, so we'll make that 4/4 instead of just a 1. So it would become 6x to the 4/4 minus 3/4, which equals 6x to the 1/4. Please make sure that you're pausing the video, stopping, rewinding, making sure that you understand this stuff. Okay, come to class with questions for me. Now we're going to do compositions of these functions. The compositions are really pretty fun because what you're doing is working from the inside out. See, I have a g of x right in here. Well, g of x means that I'm going to put this one inside of our f of x. So, because we're saying what is the f of g of x, we're saying to replace the x in this equation with what g of x is, which is this. So it's kind of like a substitution. So we do f of x with g of x, which is 4 to the 5x minus 2 raised to the negative 1. Now, what you might have wanted to do is take that x to the negative first before you ever put this in there, and you might have wanted to realize that that was going to be 4 over x to get that negative exponent removed from that. So to get it removed from this one, we would go 4 over 5x minus 2. You can either put to the first power or just leave it. First power does not have to be written. Next one, now we're going to say, well, what happens if we put this into that equation? So we would have g of f of x will equal 5. Instead of putting the x, we put what the f of x is, times 4 x to the negative first minus 2. Well, now we need to simplify this a little bit. 5 times 4 over x to get rid of that negative exponent. And that would be 5 over 1, by the way. So 5 times 4 would be 20 over x minus 2. And that's what our g of f of x would be equal to. Okay? Our last one, f of x, that means we're taking this 4 to the x to the negative first, and we're plugging it inside of that 4x to the negative first. Okay? This whole thing, the f of x, had to replace the x right there because it was f of x, f of x. Composition here. So now we can bring this negative 1 into each of these factors. It would be 4. That 4 would have a 1. Now when we multiply it, it becomes 4 to the negative 1. X will become positive 1. And now we have 4 times x over 4, which becomes x as our final answer. Another way you could have done that, remember in math there's always a couple ways, but your math should always make sense to you, so if you like this way more you could. We could think of f of x as being 4 over x, because originally it was given to you as 4x to the first power, negative first. So that's the same thing as 4 over x. And so if we think of f of x being that way, then we can do 4 times 4 over x to the negative 1, and in that case we would have to flip both of those. 4 to the x over 4, and now it could be a positive 1, and now these would cancel and you'd get x. Okay? That is the end of this section. 6.3, make sure and do these problems in class and ask lots of questions of me when you come to class. You might have a few. Thank you very much. We'll see you next class.